I'm Yue Qilin. Here I'm going to show you the solution of question 2 in homework 5. Question 2 give us the expression of fxy and y is larger than 1, x is between 1 divided by y to y. The first question asks us to join the non-zero definition region of fxy. From the y is larger than 1, x is between 1 divided by y and y, we can get the figure like this. And this area will be the area given by the condition. And now let's move on to question 2. Question 2 asks us to find out A so that fxy is a valid joint density function. From the lecture we know when fxy is a valid joint density function, that means the integral from minus infinity to infinity of fxy dx dy will equals 1. And now in the condition, the non-zero definition region of fxy we have worked out in question 1 is this area. So when fxy is a valid joint density function, the integral in this area will equals 1. So now let's move on to the solution. We'd better do the integral from the vice view, that is from look at this side, and do the integral by x first. That is x is between y to 1 divided by y, from 1 divided by y to y, and y is between 1 to infinity. Y is between 1 to infinity. So that we can get the integral in this expression. That is y is from 1 to infinity, and x is between 1 divided by y to y, fx dx dy. And we took the fxy's expression into the expression. We can get this expression, and we continue to calculate this expression. We let ln y equals w, and the expression can be changed into this form. And after calculated, we can get the final answer is a equals 2. After we got the value of a, the question 3 asks us to find out the marginal density function of fx and fy. Look back on the condition. What we get is fxy. Now we have to find fx. By the definition, fx will equals minus infinity to the integral from minus infinity to infinity fxy dy. That will be because in this question the non-zero area is this, so all the integral will do in this area. Little fy, that is minus infinity to infinity fxy dx. And then we do the integral of fxy dy. Pay attention, from the figure we can know when x is between 0 to 1 and when x is between 1 to infinity, the situation can be different to this integral. So we divide it into two situations to have a discussion. When 0 is between when x is between 0 to 1, fx will equals one divided by x to infinity, and the fxy dy, and calculated it, we can get the answer is 1 divided by 2, and also the similarly, when x is larger than 1, fx will equals the integral from x to infinity, that is from this view, x to infinity, y will between x to infinity, and fxy dy. Calculate it, we can get the final answer, and then we draw the figure of these two functions. Now let's move on to question 4. Question 4 asks us to verify fx and fy are valid density functions. When we set a function is a valid density function, that is to say, the integral from minus infinity to infinity of fx dx equals 1. This will also the same in the situation when fx is fy dy. So we make the don't forget our when our non-zero area is this area, not the minus infinity to infinity. So we can get the integral from minus infinity to infinity fy dy will be 1 to infinity, and will be 1 to infinity of fy. Fy is this, and calculated we can get the and also make the w equals ln y. We can get we can get it simple, and finally we calculated it. We can get that this expression is equals 1. That means fy is valid. Also, to verify whether fx is a valid density function, we need to calculate the integral from infinity from minus infinity to infinity fx dx, and also the question asks us to make the non-zero area in this area, so we can get the expression integral from 0 to 1, from 0 to 1 when fx is equals 1 divided by 2, plus when x is larger than 1, the expression is 1 divided by 2x squared. And then calculate this expression, we can get the final answer is also 1. That means fx is a valid density function.